Okay, so thank you for the introduction, and also I'm very happy to be here to talk about some of our research related to Metaverse, and which is also related to building and construction industry. So a little bit like introduction about so the research center at PolyU. Okay, so this is a very new research center, and we actually focus on color imaging and also Metaverse. So which means we are trying to look at how we can use sensors like cameras and also like the displays to capture and then also to present like the Metaverse like feeling or the Metaverse kind of the environment to the users. And we have this research center just established in June this year, and then we aim to provide a platform for carrying out multidisciplinary research and related to color imaging and also Metaverse. So that will actually include both of the fundamental research and also the applied research. And also a little bit introduction of myself. Okay, so my research, so when I was still a PhD student, my research mainly focused on the luminous environment, so which is actually the real world around us. For example, office, like the living room. So how the human beings are perceiving like the luminous environment or the lighting quality in real like environments. And then after I joined PolyU, I started to I started to look at how we can create or how we can capture like the real environment in the digital world. Okay, and then that's related to cameras and displays. And then in recent years, we start to look at VR, AR, and MR systems. And my research, so we look at like these two different aspects, and we also work with a lot of like world-leading companies to develop solutions and also the algorithms. Okay, so for example, I have been working with Facebook or Meta for 3 years on their new VR and also the MR headsets. So the product that was just released last week, so there are some functions is actually work out. So it's actually like developed in our lab. So if we talk about like the multimedia system, okay, so we can consider like the development of the multimedia system is coming from Web 1.0 to 2.0 and 3.0. Okay, and then if we look at like what are the platforms or the hardwares we have been using in such a development, okay, so the Web 1.0 is mainly talking about we are using PCs or laptops. And then for these systems, we are mainly using like Windows, Linux, or even the Mac OS, and to use CPUs to drive and also to perform the calculations. And then for Web 2.0, okay, it's actually coming from the PCs or the laptops to the smartphones and also the tablets that we are using. And then so the form factor is becoming much smaller. And then we are using new platforms such as the Android or the iOS. And we still use CPU, but sometimes we also use GPUs and NPUs to do the cloud computing. And this is kind of the mainstream of the multimedia systems that have been used like very widely in recent years. And then in the coming years, we are talking about Web 3.0. Okay, so we are going to use VR, AR, and also the MR systems. But so far, we don't have a very good or kind of the agreed like the platform to do the computing. Okay, so we are still using CPUs like GPUs, NPUs, and maybe also the cloud computing. But after several years, we will have agreed systems to work on, so that all different products or all different platforms can be worked together to create the Metaverse. And then in terms of the application, okay, so when we are still using like the PC or the laptops, we mainly look at the e-commerce, like the social network, and also some like and also some of the games. And when we go to the Web 2.0, so you can see that actually the applications was still very similar, except we have some like more advanced app or more advanced softwares that we can have a better interaction or the connections between different people or between different users. But now in the Web 3.0, actually we will have to cover a much wider range of the applications. So from entertainment, training, manufacturing, treatment, like design, like physical therapy, like rehabilitation, and also education. And in terms of like these applications, so which are related to the building and also the construction side, so the construction industry, I think like design and also like so entertainment and also interaction, these are the major applications that we have been looking at. And if we compare like the requirements like through Web 1.0 to all the way to 3.0, okay, so if you consider PC, laptops, smartphones, and tablets, like the main requirement we want to have from the hardware and also from the platform, we are trying to save some information and to read, to record, and also to capture and render the informations. But actually, So in the Web 3.0, when we are using the VR, AR, and also the MR systems, so we actually want to create a more realistic, more immersive environment. But also we have to provide a real-time interaction between the user and also the environment and also the object. So because we want to let them to have kind of the realistic like environment or the interactions with everything inside the metaverse. And if we want to create such a real-time, so the interaction, we have to have very good real-time capture and also the rendering. So both the capture and the rendering, they have very, very high requirements in comparison to the conventional like PC, laptop, and also the tablets. And sometimes we have to build something beyond reality. So that's kind of the virtual object we want to do. Okay, for the construction and also for the building, so for the building industry. So sometimes we want to show a room that has been decorated or that has been designed with all different systems, and then trying to see if we put different design systems or we put different kind of the decorations or kind of like the building solutions in the building, so what's going to happen? And then we can compare like different solutions or the systems before the construction, so which can help us to perform a better design. So that's kind of the requirements that we have been trying to look at how we can meet these requirements. Then, so a lot of people is kind of like get confused. What are the differences between the virtual reality, augmented reality, and also the mixed reality? And actually, all of these three, they have to use the headset. Okay, but the only difference is how we are looking at the environment inside the headsets. Now, if it's the virtual reality, so it means you can build anything you want using a software. So such as like the conventional like AutoCAD or the AutoCAD. Okay, you build a completely virtual environment. So even though such an environment can be somewhere coming from the real, so yes, so it can be somewhere coming from the real like environment, but you have to build that. So in other words, I'm sitting in the office, but in the virtual reality environment, I can actually move to any places I want. Okay, I can go to Korea, I can go to New York City. So that's a virtual reality. So you can put virtual objects inside the headsets. Okay, that does not have to be in the real environment. Now, augmented reality is a little bit different. Okay, you have to use a transparent like glass, or you have to use a transparent headset. So in other words, you can see through the headset and then to perceive what's really around you. Okay, now in this example, so everything inside the room is the real environment that's around you. And then on top of that, you can overlay some of the virtual objects. Now, for example, for this duck, okay, you can put it into the environment and then trying to see if we have such an object in this environment, okay, what's going to happen. So, and then, so for some of the systems that we have been using today for augmented reality, it's more like, so it's kind of helping you to get something. So when you are making the presentation, okay, you use the headset, and then all the words of the script can be projected in front of you. So augmented reality is actually a see-through system. You see the real environment, and then you overlay the virtual objects or the stimulus. Now, for mixed reality, is a combination of the virtual reality or the augmented reality. So you still get the real environment, but this real environment is not coming from the see-through. Okay, you are not looking at the environment from the transparent glass. Okay, we have a camera on top of the headset that will capture everything around you. And then based on the capture and also the rendering, you can put the virtual objects inside this captured environment. So even though like for the middle one and also for the right one, you see the duck, but obviously for the right one, it's more realistic, okay? Because you use the camera to capture, you use some computer vision like algorithms to detect like different surfaces. And then when you overlay something on top of the real environment, you see the thing is more realistic, okay? So that's the MR system. And a lot of times for the commercial available like products, for example, like the Quest Pro from Meta or from the Facebook, it is called a virtual reality headset, but actually it has the function to do the MR like function. So it has a camera there, so which allows you to capture the environment around you, and then on top of that, so you can overlay like the virtual objects. Okay, so VR and MR, they can be combined in the same headset, except MR, we will turn on the camera to capture the environment. But for VR and AR, okay, they have to be like separate headsets. And no matter, so we are talking about VR, AR, or the MR. Okay, so in order to provide the very realistic or the immersive kind of the experience to the users, okay, we always need to have such three steps. Okay, so the first step is to capture the environment or to do the modeling of the environment, and then you have to render that on the display. Okay, even for AR, you have to render that. So because you want to have something like to be seen by the users. And then final step is you have to show that on the display. Okay, and then from the first step to the last step, there are a lot of opportunities, but also there are a lot of like great challenges to us we have to solve. Now, the first thing we want to look at is how we are going to perceive the environment in the real scenes in comparison to the like the VR, AR, or the MR systems. Okay, so for the left figure, this is showing that how we are looking at the real environment. So all of us, we have the feeling that we have a very, very large field of view. Okay, by using two eyes, okay, we can actually see almost like 180 degrees. So you can see the entire environment. But in the past, when we are using the computers, tablets, or the smartphones, okay, the display is very, very small. Okay, in terms of the degrees, we are actually only seeing like 20 degrees. Okay, even for the smartphones, it's going to be smaller. So for the smartphones and also in comparison to the real things, okay, so the field of view is much limited. So in other words, we are not providing a very good immersive experience to the users. But on the right side, okay, you can see this is the scene we are actually seeing in the VR, AR, or the MR systems. You use two eyes to see two different displays, and then the field of view can be larger than 90 degrees. Okay, for the existing like the Quest Pro and also for the Pico like the Z headsets, they can go to around 100 like degree of the field of view. So we are becoming more immersive. But if we are becoming more immersive, this is actually provide very good like realistic kind of the environment or the experience to us. But it's also introduced the very great challenge. So the first challenge I want to talk about is actually talking about like the adaptive display. Okay, this is talking about for the human being or for the human vision system, when we are in the real environment, okay, our vision system has a mechanism which allows us to maintain different objects to be very similar in terms of the color. Now, for example, you look at a white paper and then you put the white paper under an incandescent lamp and then also under a daylight. So of course, based on the fundamental physics, we know from the daylight we will perceive more blue light, and then under the incandescent lamp we will perceive more red light. But regardless of this, you still see the paper appears to be white. Okay, this is the function of the human vision system to remove the contrast from the illumination. But the problem is if we just present what the camera captures on the displays, so in particular in the VR, AR, or the MR sets, you will feel completely different, okay, because the cameras does not have such a function. Okay, so some of the cameras, we have the white balance function, but this is still not so accurate. Now, if we present like this image in the headset, okay, you completely feel like the environment in this, so the environment presented on the headset is too blue. But if we present like this one on the headset or on the displays, you will feel it's too yellow. Okay, we have to do something to make sure that the environment that we are presenting inside the headset match to the perception that we have in the real environment. And this is particularly important when we just put on the headset. Okay, you don't want to make the people feel that, okay, the real environment is kind of the warm lighting, but when you put it on, okay, it's very cool lighting. Okay, then you make the environment or the experience not so realistic. And based on this, we actually carry out some experiments with Facebook. Okay, so this is what we build in our lab. So the left side is actually we use the tunable light source to produce the real environment. Okay, so everything inside the booth is the real. And then on the right side, we actually build another viewing booth we call the virtual light booth. Okay, we have a very large display trying to simulate how the observers or the users will experience in the VR, AR, or the MR headset. Okay, you can see that based on very accurate like algorithms and also our tuning, we can make the scene show on the display to be very similar to the scene show in the real like environment. And then in the experiment, we actually push the display to the back of the booth and then to have a small opening at the front. So the observers or the users actually look through this opening and then try to see how they feel when they are looking at the big display, which occupy a very, very large like field of view. And so we use like tunable light source and trying to see that, okay, if the real environment is kind of the cooler, so how we want to have the displays to show the rendering of the of the environment. And then if the environment is kind of the warm lighting, how we want to tune the displays. Okay, and then we find there are some very significant like differences between the real environment and also how we want to tune the display. And this this will be built in some of the future products. Okay, that's very soon. So that's the first challenge. Okay, we want to present or we want to make the scenes inside the headset to be more realistic. Now this is only talking about the scene. Okay, and then how we can make sure, except the scene, like different stimulus or different kind of the object inside the headset to be realistic. So this is a very huge limitation, not only for the VR, MR, or the AR headset, that's also happening to our displays. Okay, so in the real environment, okay, actually our human visual system can perceive a very wide range of the color and also the brightness. But for the displays, we can only produce a very limited range of the colors and the brightness. So we have to compress the range of the color and the brightness so that we can show that on the display. Now the problem is for conventional displays, so because the field of view is so small, okay, you don't perceive a very wide range of the colors and also the brightness at the same time, okay, because for example, I'm looking at the display, you only need to make sure that, okay, the areas coming from the display is enough for us to present on the display. But the problem is now we are talking about the VR, AR, and also the MR systems. We use the camera to capture very large field of view. Then that means that we have more opportunities to simultaneously capture the bright area and also the dark area. Now, for example, this is an image that if we present on the conventional displays or on the conventional like smartphones, okay, you only see such a field of view, so which is actually like relatively small. But now if we want to present that in the VR or the MR systems, now you can see that we want to use a very large field of view camera, and then we can capture a very large a very large like field of view to present that in the headset. Now we will have these dark areas, but we will also have these bright areas. Now the problem is in the real cases or in the real scenes, our eyes can see these two different brightness levels at the same time. But for the displays, we cannot do that. Okay. And then, so this is actually what's happening in my office. Okay, I'm standing in the hallway, and then we have a window here. Now, if I want to capture myself so in detail, I have to increase the exposure time. But if that happens now, so we cannot see anything outside the window. But if we want to capture what's going on outside the window, we have to reduce the exposure time. Now we see what's going on outside the window, but you don't see like my person like inside the hallway. So such a high contrast is actually can be perceived by the human beings in reality, but we don't have a camera that can capture such a high contrast. So we are doing something trying to see that, okay, based on where we are looking at, whether we can do something to tune the camera and also to tune the display so that we simultaneously present what we see in the real case. So this is only talking about like the range of the colors and also the brightness. Now the third thing is, okay, because we have the VR or the MR systems, a lot of times we are talking about how we can put some virtual objects or the virtual like stimulus inside the scene. Now, for example, for the building design, we want to put a sofa or a virtual desk inside the room and then to see whether it fits the entire kind of the environment. Okay, so we can change different things. Now, everything we have like different colors, but how we can present these virtual objects. Okay, now, for example, for these, like for image, okay, we always have a virtual object inside this viewing booth. And then you can see that like for this red one, so for this red cross and also for this red cube, well, generally speaking, you feel, okay, it's still kind of the realistic, except we don't have any shadows around that. But generally speaking, like the colors, but because you don't know what's the red we are talking about, you generally think it's acceptable. But the problem is, if we are talking about white objects or the neutral objects, that comes the problem. Now, for example, like this cube, like very obviously you will feel it's not so realistic. So because the brightness is too high in comparison to other objects inside this scene. But if you reduce the brightness, okay, it will appear as gray. So which means that we care about how we should render the virtual objects very carefully to make different objects to look realistic in these in these metaverse like environments. Now this is what we did in the in the Apple, so they call it AR kit. Okay, so this is the same like environment on my desk, and then this teacup is actually a virtual teacup. Okay, you can see that we have the shadow. Okay, it's kind of the realistic, but the problem is the color of this teacup is not so good. Okay, so when my desk lamp is kind of the cool lighting, okay, you can see, well, the color of the teacup is okay. But the problem is if the desk is warm lighting, and you will feel this teacup is not so realistic. So because under the warm lighting, okay, you know some of the white objects, they never appear so kind of the bluish, or they never appear to be such a degree of the white. Okay, they have to have a little bit like yellowish of the white. So this is the problem that we put the virtual objects inside the environment, but the color of this virtual objects does not change with the lighting condition. And this makes the object appear, or to make the object looks like not so realistic. And then based on this, so actually, so Apple, they did something. Now, if you put this teacup in a different environment, and you can see that they slightly reduce the luminance or the brightness of this virtual object. So you don't have a strong feeling to say, okay, this color or this white is not so realistic. So they compensate like the color shift with the brightness. Okay, there's a lot of details can happening like behind this. And based on this, we actually build so other systems and then trying to see how the human beings are perceiving the virtual stimulus under different conditions. Now, this is what we are building in our lab. Okay, so this is actually a reflective mirror. So in other words, we put an iPad here, and then we have a color patch here. And then the color of this color patch can be projected to the back of the viewing booth. So this patch, even though you see the patch is there, but it's not a real patch. Okay, it's coming from like this iPad to be projected to the booth. And then we ask the observers or the user to judge what's the color of this color patch. So which is actually a virtual patch in the real environment. And then this is we are simulating the AR condition. Yeah, and this is another system that we have been building. Okay, we use a larger mirror and then with a larger booth. And so we are not only talking about the color patch here, but because a lot of the times in real conditions, we are looking at the 3D object. Okay, now in this case, we are showing the color patch, the 3D cube, and also some complicated shape of the stimulus. And we also have two different depths. Okay, so for this one, when we project these things from the display into the booth, okay, it's actually overlaid on the surface. But now so if we move the virtual object to this side, so you will see that the object is actually appear in front of this, so this piece of the paper. So it's kind of floating in the air. And then we want to see how does that will change like the color appearance perceived by the users. So all of these, they are talking about like in terms of the color, the brightness, okay. And then another thing, this is very like critical or important, is how we are actually perceiving the environment, like using the headset, okay. Now this is the real thing, okay. In the real cases, when we are in the real world, we always use two eyes to perceive the entire world, and then these two eyes, they work together. Okay, you cannot control so one of your eyes. So these two eyes, they are actually looking at the same object in the environment, right? You look at one point, now two eyes will see the same point. But for computers, okay, it's kind of the same thing. Okay, you use two eyes, and then every time you just see one display. Okay, but for VR, AR, and also the MR system, you have two displays inside the headset. So left eye will see something, and then right eye will see something, and then they never match. Okay, so the reason we make these two images to be different is actually we're trying to create the depth of the 3D like feeling, and this is very important for building and also for the construction industry. So because we want to let the user to feel, okay, what's the spatial kind of the feeling of this space, and then what's the size of the space, and then how far it is to the to the person. Now, so when in the real scenes, okay, we use two eyes to see two identical displays, or because we are seeing like two. So we are seeing like the two images coming from the same objects. So there's no difference to the eyes, right? So one point, the color is always the same. And then the second thing is the distance of the display will change with the object. Okay, if the object is very far, and then you are looking at it very far. If the object is very close to you, then your eyes is moving to the distance to be shorter to you. But for the computers, okay, it's a little bit different. Okay, two eyes is only seeing one display. Okay, it's the same display, so there's no differences to the eyes. But the point is, we don't have the depth information, right? So because no matter the object is very far to you or very close to you, they're always coming from this display. Okay, you don't have the depth or you don't have the 3D information. But now for VR, AR, and also the MR system, so as I said, two eyes will see two different displays. And because of the production like details, you can never have two displays to have the identical like parameters. There are always some differences. But the problem is such a differences does not happen in real cases. So how we should tune the displays, or how we should make sure the two displays is producing the image with such a tolerance that the human beings or the users will not complain. And then the second thing is the object distance does not change with the display distance. So because you put on the headset, the display is fixed at that distance. But in order to show the depth or show the 3D information, so actually we do something and then trying to see that how we can make the users or the human beings to perceive different distance. And then the techniques that has been used in the headset is actually the size or the places inside the two images will be slightly different. Now, in this case, if we want to make the objects to be perceived to be very far from you, now these two images on the displays will have some differences. Okay, it's not at the same point on the display. But if you want to show this object at the distance of the display, so these two will be overlapped to each other. Okay, so the light is coming from the display, and then you feel the object is located there. But now if you want to make the object to appear very close to you, now you see that we have to move the right eye to see the image put on the left, and then the left eye to see the image on the right, so that the intersection point here is actually the feeling you want to create for the users. So these are the things that has never done before, and then this only happens when we are talking about the 3D perception inside the headset. Now, if that's the case, then what's going to be the problem? Okay, so the problem is, because we want to create or we want to capture a very large field of view, we have to use the fisheye lens instead of the normal camera lens. Now, if we use the fisheye lens, we always have different types of the fisheye to do the projection. Okay, so you see that this is a space, or this is the classroom. Now, if we use different cameras to capture the classroom, okay, we will have different like geometry like distortion. And then if such a geometry distortion is a little bit different between the two eyes or between the two displays, and so if we combine them together, so what's going to happen? Okay, we find actually human beings will be very sensitive to a very slight differences of the image perceived by the two eyes. Okay, we are still looking at this problem. And then the second problem is not only talking about such a geometry like differences, we are also talking about so the two images, they will have slightly like different brightness and also the color disparity. So in other words, like the brightness between the two displays on the same point can have a difference around 10%. But how does that affect your brightness perception and also the color perception? So we still don't know. And then the second thing is like these two displays, they will always have a little bit like slight so the distance like difference to your eyes. Okay, maybe one is a little bit closer to you, so with 0.01 like meter, but that will actually affect your depth perception. And because we are seeing the two different displays, but we are creating the depth information, so we care about the binocular like fusion. So you don't want to say that, okay, two eyes seeing two different images, and then we don't feel like these two images, they overlap on each other. Okay, you see two objects. Then that's the thing that we really want to get rid of. Then the last point is actually like the geometric like distortion due to the lens distortion. So because everything we have been talking about is coming from the display itself. But in the headset, we always have the lens to be placed in front of the display so that you can see the very large field of view, and then also to see like the image to be projected to a certain distance. Now the problem is how we should design the lens, and then how we should calibrate the display together with the lens, so that we make sure everything we want the user to see is the thing they see. Okay, these are the challenges that we are actually addressing with like different companies to see how the human beings are perceiving the world inside the metaverse or inside the headset. And finally, to conclude my talk, okay, there are definitely a lot of opportunities for the building and also the construction like industry to make use of the metaverse and also to make use of the AR, VR, and also the MR systems. Okay, it provides more freedom for us, and then it can provide more immersive and kind of the realistic experience to the users and also to the designers. But such a realistic or the immersive experience actually coming with a lot of challenges. Now, how we should actually try to produce such a realistic experience, both about the ambient conditions and also about the objects inside the scene, okay, including the real and also the virtual scenes and the virtual objects. So these are related to how we can make the cameras to work properly and how we should process the image and to show the image like properly. And then the second point is we have to consider that when we are perceiving or when we are using the headset, the binocular like vision in the headset is completely different from our so it's completely different from our vision when we are looking at the normal displays on smartphones or on computers. Now we have to be careful about the image processing and also the rendering for color, for brightness, and also for geometry, so that we can provide the realistic and also the comfortable experience to users. Like if there's a little bit or something wrong in this pipeline, and then when the user feel uncomfortable in this metaverse or when they are using the headset, then no matter what you do or to make the image to be more kind of the beautiful, that does not really help to us. Okay, I think that's all I want to present, and I'm happy to take any questions.